Hello guys, how are you all? Welcome to today's new and amazing live stream. Today we are gonna solve a few very important DSA questions which are like extremely important. Also the best DSA questions. What we are gonna do today is we are gonna solve a very most important questions and also at the same time a few of my favorite questions. So how are you all doing? I hope you are all fine, guys. So we'll go to our first question of the day. The first question of today is N Queens, a very famous as well as a very important question from all the interview perspectives, all the DSA coding round perspectives. One of the most frequently asked as well as one of the most amazing and also one of my personal favorite questions. And we'll go for the question. We'll see the question. You are given N Queens. The n-queens puzzle is a problem of placing n queens on an n cross n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. So like if there are 5 possibilities and what do I say, like the order of the puzzle, like the way we are returning the solutions, for example 543 or 345, both are same, we can return in any way we want. Each solution contains a distinct board configuration of the n queens placement where q and dot indicate both queen and an empty space respectively. So queen is marked as q and dot is marked as an empty space. So here we are given with a board n is equal to 4 where it's dot q dot dot. So it means that the queen is on the second position in the first row, and next dot 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 q, which means that 3 empty spaces and then queen, and next it is q and three spaces, which is queen followed by 3 empty spaces, and then it's 2 empty spaces and queen and then an empty space, and the next board is, so here if we check this board there will be two distinct solutions for this 4 n queens puzzles. If we take any position, for example n is equal to 1, our output is gonna be like q, because in 1 cross 1, like 1 cross 1, which is basically 1 square, the only position will be q. So in a 4 cross 4 matrix, or sorry, in a 4 cross 4 matrix or any 4 cross 4 grid, there will be 16 squares in which there are 4 queens. So what is the number of ways where we can make sure that no two queens will take? Okay, we'll go for the constraints. Given the constraints are n is lesser than 9 and lesser than or equal to 9 and greater than 1. So basically there is no zero case here. Well, if zero case is there, zero is zero only. So yeah, it's not a matter. Now I'll go to the question. So the first question, n queens. So guys, they have given us a, okay, you take a example here now. So guys, we have what do you say, 3 cross 3 matrix or 4 cross 4 matrix as given in the question. I'll indicate wherever the queen is present in dots now, like for, or else I'll just write Q. Which are the positions? 2, 4, 1, 3. Okay. Queen, 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 and in the third position, queen. So this is our thing. In a chessboard, this is, they have given that it's a chessboard. A queen can move. A queen can move in this in right to left, like across all the rows and columns. It can move across rows, and also it can move across columns, and also it can move across diagonals. So we have to make sure that there's no queens in the same row, no queens in the same row. Like a queen and a queen can't be like this. And also we have to make sure that there is no queen and a queen like this. And also we have to make sure that there is no queen like this in the diagonals or like this, both the diagonals. So we have to ensure all the 4 conditions. So we have to check all the 4 given conditions, and they have given us the constraint as 1 being the smallest, n, and lesser than or equal to 9. So there is no case of 0. When it's one box and it's queen, this is the only possibility. Like if we place it here, it's done. So the output is gonna be 1. When it's 4, I'll draw both the possibilities in 4. So this is a 4 cross 4 grid or a 4 cross 4 chessboard. We'll take it as a 4 cross 4 chessboard itself, since it's given in the question. So the first possibility is queen, 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 and a queen. And the second possibility is, anyone in the chat, what can be the second possibility? Guys, anyone, what can be the second possibility? It will be very similar to this. It will be very similar to this, guys. Anyone in the chat? Anyone in the chat, guys? What can be the second option? Very similar to this. It's just the reverse of what is given. In the first, it will be here, Q in the third position, and in the second one, it will be in the first position, then in the fourth position, and in the final row, it will be in the second column. So these are the only 2 possibilities when it's a 4 cross 4 matrix. And we have to return the output as 2. These are the two distinct boards possible. Now we'll go to solving this question. What can be our approach or intuition to solve this question? Anyone in the chat, what can be our intuition to solve this question? Anyone in the chat, what can be our approach to solve this question? Guys, anyone, how can we solve this question? Come on guys, it's a simple logic. Try in the chat once. How can we solve this question? Anyone guys? Anyone in the chat, how this question can be solved? Okay, we'll continue this since I'm getting no replies. What is the intuition? What is gonna be our intuition, guys? There's a the question is very obviously like we can get it. It's a backtracking problem. It's a it's the best example for a backtracking program, according to my personal opinion. It's just like a classic backtracking problem where there are n queens in a n cross n chessboard. N queens. This question is asked in multiple interviews in different names. For example, five queens, or for example, eight queens. Eight queens was recently asked in some. I'm not sure about the company, but it was asked in a company's interview, which was actually told to me from my seniors. It was asked as an eight queens question, which is the same as n queens. Here it's from 1 to 9. There are only 8. So I already explained what is gonna be our intuition, the conditions. Basically, the first one, no same row, no two queens on same row, on same row, next on same column, and also on the same diagonal. So now this is our intuition, guys. We'll go to the approach, which is very important for this question. Approach. What is the approach? Chat, anyone? Which approach we can follow? I already said it's backtracking, so yeah. Chat might be able to guess it now. Come on guys, try. What can be the approach for this? Anyone guys? Okay. Let me see how this question can be solved. What is the approach? First one, the first step of this. First step is bitwise representation for constraints. Bitwise bitwise representation for constraints. So in this step, what we'll do is basically we'll use 3-bit masks. 3-bit masks. What are this? One is shadow 0. The second one is shadow 1. And the third one is shadow 2. The first one, shadow 0, is for column restrictions. The shadow 1 is for rows. Sorry. Just made a mistake, guys. The shadow 0 is for column restrictions. And the shadow 1 is for left diagonal restrictions. Left diagonal. And the shadow 2 is for right diagonal. Right. So these are the restrictions. Restrictions. So now after this, what we'll use is we'll use with this first step itself, we'll use bitwise operations. We'll use bitwise operations so that we can quickly check if placing queen in I comma j is gonna be valid or not. Or not. First step, guys. What is gonna be our next step after this? After this, in our second step, we'll do one very important step, the main base of this whole solution of this. In the second step, we are gonna do backtracking with recursion. You all are aware of recursion. A function calls it by itself. The first thing, backtracking with recursion, here what we'll do in the first step is we'll place queens row by row. Queens are placed row by row. So if the queens are placed properly, we are placed in the companies. And after that, if we can place a queen in column, if we can place in column, if column, then will recursively move row by row. Will recursively move row by row. And after this, what we'll do is, if all the rows are filled, all rows filled, then we store we store valid board configuration. We will store the valid board configuration. Now, after this, what we'll do is, we have to optimize this, guys. How are we gonna optimize this? For optimizing this, the first thing we'll do is, okay, the next step, optimizing. Optimization. For optimization, what we'll do is, the first step, using bitwise operation. Using bitwise operations. Will not use an array here. Instead of array, will not be using an array here. Instead of an array, we'll use bitwise operations. Bitwise. So, what we'll do here, if is smaller than j, we'll use 1L smaller than j, so guys, now I'll just explain this whole point again. Here, we are not taking arrays. What we'll take instead is, we'll take 1L, which is a long int, whose value is 1, and then we'll perform left shift. We'll use left shift operator in Java, and then if 1L is smaller than, sorry, if 1L is left shifted with j, this is our first step, to check j is occupied. To check j is occupied or not. Occupied or not. Now, in the next thing, after this, what we'll do is, similarly, if shadow 0 not equal to, Okay. Now we'll go to the next bitwise operator. We'll be using bitwise OR if shadow 0 or cell, we'll then left shift it 1. What will it do? It will update the left diagonal. It will update left diagonal. Similarly, we'll do for shadow 1 and cell. This is shadow 0. Now shadow 1 and cell, sorry, shadow 1 or cell. I was just telling and in the sense and. Shadow 1 and shadow 1 or cell. This is for update columns. Update columns. This is for updating columns. And the next one we'll do for shadow 2 or cell. We'll right shift here and this is for right diagonal updating. Updating right diagonal. So once we are done with this, after this, the final step, we are left with one final step. What we'll do here is for optimizing itself, we'll use, okay, sorry, not the second one. I'll just put as a second point. We'll use abstract list for lazy evaluation. So anyone in the chat, what is lazy evaluation and what is an abstract list? Anyone in the chat, guys? What is abstract list and what is lazy evaluation? So guys, what is lazy evaluation first? Lazy evaluation is a technique which we'll use in like for example, we won't be needing every values, and we need to not store all the given, like all the values that are computed. We'll use lazy evaluation in that time. For example, it is gonna delay our computations until when it should actually be the mostly needed, and also it will improve the performance by avoiding unnecessary calculations. It saves memory, as I already told, because it won't be using all the spaces. And also this is used for memoization. Basically, you all might be knowing with DP memoization. Now what is an abstract list? Abstract list is a Java class which will give us partial implementation of list interface. This is gonna give us partial implementation of list interface. uh, with this we can actually develop custom lists, like we can actually create custom lists by by just implementing the necessary conditions like get or size, like this get or size. By using these things we can actually get the like required list. Now we'll go to the code. So n queens, this is all importing which is already imported. I can just remove this also. But yeah, like keep this in mind. You have to import abstract lists, arrays, and util like list all the types. You can just remove this also. There won't be an issue. Now, now we'll go on adding hash. Like we'll go on adding commands so that we can understand this code better. The first one, builder function. So guys, we'll add commands for this question. The first one, the builder function, it's used for final valid solutions, storing final valid, and the template board is actually the chessboard, board state for recursion. And then the template, it's gonna store the pre-computed row templates. Okay, what will template do? Pre-computed row templates. And what about board? Recursion, it's the board state for recursion. Board state for recursion. Now, after this, we'll just like take it list. Now, the next step, what we'll do is this all just calling the function, overriding and initializing. After this, we'll come for this thing. Public list string sol queens 1 int n. This dot n is equal to n. This dot builder is equal to new array list. Will come for this. Here is the main code for us. Here, character array is there. New character. This is used to fill row with dot. Fill row with dot. Array dot fill. Sorry, I didn't see the line. Arrays dot fill is used to fill any array, like given array, and we can fill it with any given thing. Like for example, if I change a dot with comma here, it's gonna work with comma. Dot. Here we need dot, so we are using dot. Here, this is for row template. This array is for row template with single queen in each column. After this, we'll run a for loop. Line I equal to q. Why is it? Place queen at, this is to place queen at column I, and next template I is equal to string dot value of line, and then line I is equal to dot. Why is this used? It is used to reset, basically for reset for the next iteration, so that there won't be any errors there. Now here comes our very important step. which is will start backtracking. Here is where we'll start the actual backtracking. We'll start backtracking from which? From row 0 with no constraints. Now, we'll return the builder. Now we'll do the bit manipulation here. Shadow 0 or shadow 1 or shadow 2 bitwise operators. For this is used for compute the attacked columns. And after this, we'll use one more for loop in j equal to 0, j smaller than n, j plus plus, and we'll bitmask the bitmask for column j. We'll bitmask for column j, and after that, if the column is safe, we'll use a if condition. If column safe, we'll place the queen. We can Here we'll use board I is equal to template j to place the queen. If I is equal to n minus 1, which is all rows filled, then we'll store the board configuration. Or else, if not, what we'll do is after in this else condition, what we'll do is we'll recurse to the next row with updated attack mask. Updated. Now, that's all. A very simple code. Not actually very simple. It's actually an advanced question itself. It's a hard question. It's actually hard if we don't understand it. Now we'll run this code. Shit, guys. Okay, I should not have deleted all the importing. Import java.util.star. I'll just import everything and then I'll run it. There. Okay, guys, I had removed thinking that everything is already given here. Uh, in the starting, if you remember, I removed import java.util.arrays, array lists, everything I had removed. We should not remove it because we are using abstract list, which is not normal. Now I just imported everything using util.star. Now if I run it, it's accepted in the given test cases. Now I'll submit this code to check if it works for every other way. And it beats 100% of the users. And it's the best possible code to be returned. Now, we'll come to the question like a writing pad. We'll see what is the time complexity and the space complexity. Anyone in the chat, if you say what is the time complexity, I'm gonna pin your chat. If any one of you in the chat says what is its time complexity, I'm gonna pin the chat till the end of the stream. And I'll again give a shout out at the end. Anyone, guys? Anyone guys, what is its time complexity? Anyone guys in the chat? What is gonna be its time complexity? N Queen's question, what is the time complexity? Guys, it's O of n factorial. It's O of n factorial. There are O of n factorial possible ways to place queens. Possible ways to place queen. To place. Now, for the bitwise operations, it will take O of 1 bitwise. We all know that. Now, so the worst total time complexity of this is gonna be O of n factorial. We'll see what lead code says about its time complexity. We'll submit it again just to check what lead code says about its time complexity. We'll see if it's able to detect it properly or not. Okay. So yeah, you can see here, it's not making any mistake of n factorial. And what about the memory complexity or the space complexity? In space complexity, there is actually nothing more. It's exactly the same as what is our time complexity. But here it will take O of n. Why O of n, guys? Time complexity is equal to O of n factorial. Now space complexity. It's gonna take O of n for space, for stack, recursion, for recursive stack, for recursive stack, and next for board and template, it will again take O of n. So with this, the total time complexity is gonna be O of n. Now we'll just see some very important, what do you say, we can say it like takeaways, like key takeaways from this question. Sorry guys, I'll just take it as key takeaways itself. Key takeaways, the first one is bitwise masks track column and diagonal efficiently. Track column and diagonal efficiently. Okay. And the next point here is, the other major takeaway here is, we'll use backtracking. This is the best backtracking example. Backtracking, and the third point here is lazy evaluation. We'll be using lazy evaluation. I told you guys can just rewind the stream and check lazy evaluation. And then we'll also be using one more very important thing. We'll use optimized space usage. Like we'll be optimizing the space usage. Space usage is optimized It will reduce the use of unnecessary arrays, extra arrays, and it will also reduce the memory footprint. So guys, these are the main key takeaways from this question. With the even for n is equal to 9, we need very high level of optimization. So now I hope everyone are clear with this question, guys. My personal favorite question in Queens, a very important backtracking question. It's consider it as a must for everyone who is practicing DSA, sitting for interviews. It's a must question, a classic example of a backtracking, bit masking, and recursion. Everything is touched like backtracking, recursion, from basic recursion till backtracking. A lot of things, bit masking, bitwise operations, overriding, and pre-computation of arrays, like pre-computing the row templates will be pre-computing, will be setting the board state for recursion, will how to place the queens at columns, everything, a lot is there. It's a very amazing question. I hope everyone are clear with this. Any doubts, guys, for anyone? I guess all are clear with this. Yes, Procoder, you had answered correctly. The time complexity is of n factorial. So, now we'll go to our next question. Another classic DSA question, like OG DSA question. Today I'm solving all the OGs. Wait, I'll just show you a video for this question. Before we'll explain the question and all, I'll just show you a video. I'll pause the stream for a second. We'll go to YouTube. Okay. Just a second, right? I'm trying to find that question. I found the question, but this is one more very famous man question. Like, you all know what are the man companies: Meta, Apple, Amazon, Microsoft. All the top Microsoft is not there, yeah. Amazon, Apple, and Google, and also Microsoft, Salesforces. All the top companies actually use this. I'm trying to find the meme. There was a very famous meme from some movie. I'm just trying to find that. Okay, I could not find a movie meme, but yeah, I can find the example here. We'll come back to our stream. So, what is this? Trapping rainwater. A very important question in terms of placements. One of the most important questions, and also one of my personal favorite questions too. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So, there was, imagine it's a graph basically, imagine it like a graph with some spaces. We have to make sure, like, we have to see how many, like, how much water it can trap. when it's raining and how much water it can trap. I'll just show you a small video which will explain what exactly this is. It's just a meme kind of video, but yeah, you can see this guy here. I'm sorry. Yeah, you can see this guy here. What he's doing is he's just taking water from one side and dumping to the other side to fill it, and the water is getting stored here. Like he's dumping the water there, and again it's getting stored. When both are filled, it will start to overflow. So we have to fill all the boxes with water, like all the empty spaces with water. Now we'll go back to our question. We'll close this tab. We'll close this tab. We'll go to our question back. So we'll go to our writing part. Here we are trapping water, trapping rainwater. Second question, trapping rain water. So basically, like what, like I'll just draw a simple example to show. Imagine it's a filled empty space here. Here it's a block, empty space 1, empty space 0, 1, 2, 3, 4, 5. I'll just draw it till here. Now I'll put this also this much, and here let it be 1, 2, and 3. Like nothing till 3. This is 3. This is 2. This is 1. Now we'll see how much water it can fill. So here in this empty space, I'll change the color to show how much water it can fill. I'll show you guys. I'll just change the color. Okay, here we go. I'll change it to blue itself to show watercolor. Yep. So here we can store 1 unit of water, and here 2, 1 and 2. So this is where we can trap the rainwater. Now we'll just extend this graph to a little bit long for better understanding. Now imagine there is one more here which is like this, up to third. We'll take it 6, 7, it goes on. Here also it goes on. Now it's up to 3. I have to change the color. Now here also the max we can fill is 1 and 2. This one and this one. We can't fill here because I'll again change the color. We can't fill here because this is not of the same height as this. Here we have a height difference. So this is the maximum we can fill. So 2, 2 and 1. We can totally store 5 units of, like we can trap 5 units of rainwater here basically. I guess you understood how this question works. Now I'll go and see all the constraints given here. So here what is the constraints? Finally we have to give what is the amount of water which will be filled there. Oh shit, I'm sorry. The amount, the constraint is n is equal to height dot length, the length of the height, and also n is always smaller than 2 into 10 power 4, smaller than or equal to 2 into 10 power 4 and greater than or equal to 1, which means that n is in the range of 1 to 2 into 10 power 4 with including both. Now height of like height, indexing of height is from 0 to 10 power 5 including both 0 and 10 power 5. With this, we'll see the intuition and the approach we can use to solve this question. I guess you guys are clear about the question. Now, we'll see what is the way we can solve this question. Water tapping, water trapping. So, intuition. Intuition here. What is the intuition? Which is the color? Okay, I'll change the color again. Red looks very odd. Yep. Intuition. What is our intuition, guys? Our intuition will be, we can visualize this problem. I already showed you guys a meme, as well as I drew a whole diagram and I showed how this can be visualized. It can be visualized by placing two bars and imagining them as heights and water getting trapped in between them. And we need to find the minimum one. Like the minimum is what minimum in the adjacent is what the maximum amount of water. For example, we'll consider this as one. Okay, I'll change the color again. Okay, we'll make this into three levels now. First level, second level, and the third level. Now we have to check for the minimum. First level can be filled and second level can be filled. And here first level, second level, and third level can be filled. This is of 4 levels doesn't mean that this can also fill 4 levels. We have to and also this can fill 4 levels. We have to check this can't, even this can't. Why we have to? That's why we have to check for the minimum. Minimum height. Minimum height. So this is a main thing. Height depends upon height depends, or else we can just say cancel this. Okay, fine. I'll erase it. We can just say water trap depends upon minimum height. This is just very basic thing. So after this, what we'll do is we'll go for the approach. Okay, guys, we'll go for the approach. Anyone in the chat, how this can be solved? Just tell me the name of approach. Like recursion or dynamic programming or greedy approach or pointer approach, like single pointer approach, my two pointer approach, or what we'll be using for this question. Anyone in the chat, guys? We'll be using. Okay, anyone in the chat? What we'll do? We'll initialize two pointers. We'll initialize two pointers left, which is starting from 0. Start from 0, 0, and right starts from n minus 1. From n minus 1. After this, in our second step, what we'll do is max and right max. Right max. For what? For the maximum heights, we'll be seeing from left to right. Max height from left to right. From left to right. L to R, left to right. Now we'll go to our third point. If left max, if left max is smaller than right max, what we'll do is we'll move left to right. move left to right, update left max as left max to left max, comma, height left. Now, after this, what we'll do is in a third step within the second point, within this third point, water trapped at particular index, water at particular at index, particular index, water at particular index, it will be given as anyone. What can it be given as? I'll say it myself, no issues. Left max minus height of left, height left. Now we'll come for the right pointer in our fourth point, right pointer. Otherwise, if left max is not smaller, for example, if left max is equal to or if it's greater than the right pointer, what we'll do? Now right pointer, we'll go to the right pointer and what we'll do is we'll move right to left. Okay guys, we'll move right to left and after this is same exactly what we did with the left. But here the direction just changes to right, that's all. Okay, next step is we'll update left max. Sorry guys, I'm really sorry. We'll update right max. We'll update it as max of max. Okay, I'll just ignore max. Anyhow, we'll be knowing it's max of right max, comma. What is the other thing? Height of right, height right. Max of. I'll just write here also. In the left also it's max. It's max of. Now, that's how we are gonna solve this. And the last and the final point is water is given by water. Water, not wafer. Water is given by very easy. Again, same. Right max minus height right. Height right. With this, what we'll do after this is now the last step. Fifth step is we'll keep repeating the steps. Repeat until right meets left or left meets right. What guys? Until left meet right. Don't try this in real life guys. It's just in code. Now we have got the question. We'll go for the code. So guys, we'll now go to the final code and we'll add the commands for better understanding. This is like the most optimized 8 lines of initialization and just some 10 lines of code, 10 to 12 lines, excluding the brackets, it's just some 8 lines. Very simple code, but yet very important one. Now, we'll see class solution which is given, public int which is also given. Now, first one, int left, 2 pointers at both ends of array, 2 pointers at both ends of array, and after that we'll use this left max and right max. Why are we using this? These are the variables to keep track of height from left to right. From left to right. Now after that, finally int water is equal to 0, initially water trap, variable to. Now this is where the amount of water trapped is shown. This is basically the storage bin. Storage, water tank. I'll write it as water tank. This is basically a water tank. Int water is a water tank. Now our first step in our 2 pointer approach, while left smaller than right, 2 pointer approach, 2 pointer approach, if we'll use a if condition, if left is smaller, we have to process from the smaller side. If left smaller, process from left, else we'll just do all this stuff. Left plus plus to move the pointer to left, move to left, and then we'll update the left max value, update left max, move left plus plus left to right, and then update left max, else right minus minus. What is this right minus minus? Move right to left. All the other stuff are exactly the same. Okay, this water plus is equal to, which is water is equal to left height max, and it's just incrementing it using shorthand. This is water trapped at left. Now max, update right max, and after that finally water trapped at right side. Finally we'll return the water, which is basically this both sides, total trapped water. This is total water tank, total water stored. Now we'll run this code for the given test cases. It works perfectly, and now we are going to submit the code and check if it works for all the given test cases. How? It's exactly the same code, guys, which I ran. It's some issue with the lead code. I'll submit the question again. Wait. Okay, exactly the same thing what we have done is what is given even in the 0 millisecond code. Actually, this is the most optimized code itself, guys. There is some issue with the lead code. It's not loading. Maybe submission queues. We'll see. Oh my god. It might be because of slow internet. Not sure why this is happening, guys. We'll just check out with the most optimized solution according to lead code. What we have done is exactly the same. Exactly the same thing. In cleft, we have took left, right max. Then while left smaller than right will go to from left to right. Then again right to left. This is the exact code, guys. I'll just copy paste this without commands now. We'll see. I mean, I'll submit it now and see what will be the change. See, guys, it's some technical error with the issue. It's not the issue with the code. So this is the most optimized code. You can trust this. Let it be. With this, we are gonna end today's stream. Today we solved two of the most. Okay, before ending the stream, I'm sorry, guys. You have to see the time complexity, and the space complexity. The time complexity of this question. The time complexity of this question is, or this given particular code. In the particular code, it is gonna be every index, each index is processed once, processed once, is processed once to move from left, to move left and right pointers. Now, towards each other. So, it's gonna be O of n. The total time complexity is gonna be O of n. Time complexity is equal to O of n. What about the space complexity? Space complexity is pretty much very clear. It uses very few extra integers like left max, right max, right max, what else? Water, left and right. I guess that's all are used. So it's gonna be O of 5 basically, which will get reduced to O of 1. So the space complexity is equal to O of 1 for the given question. Are there any doubts, chat? Anyone in the chats, any doubt? So guys, with this, since there are no doubts in the If you have any doubts, please put it in the comment section. I'll be replying to all the comments and I'll just answer it through the comments or in my next stream, which is gonna be tomorrow at sharp 9:45 p.m. We'll be reviewing Lead Code's bi-weekly contest. And there is a chance that I might give the contest as well tomorrow. So guys, until we meet tomorrow, have a good time. Enjoy your day. Good night. Thank you for joining the stream. Before leaving the stream, please like, share, subscribe. Subscribe to my channel. Share the video, share the channel. Keep the notifications on so that you'll be notified whenever the next stream starts. With this, we are going to end today's stream, guys. Bye bye. Have a nice day.